All right, folks. Want to just finish up with these last couple of slides we didn't get a chance to get to in lecture today. Just finish up with last type of research that we're going to cover for this unit. So in class, we had finished up talking about correlational research. And again, just as a reminder with our correlational research, we're looking at whether variable X and variable Y are related to one another. If you recall, we're looking at correlations at a very basic level here, looking at scatter plots, seeing if, in general, if X increases, does Y increase? Last example we gave here was the relationship between Quiz 1 scores and final grade. Looks like these have a positive relation. As X increases, Y increases as well. And we see that reflected in our correlation coefficient here. So our correlation coefficient of 0.66, it's not 1, it's not perfect, but it's still pretty strong. It's also positive and not a negative coefficient, so that we know that as people tend to do better on this first quiz, their final grade also tends to be better. Now, as we had talked, the limitation of correlational research is that we can't establish causal relationships. It doesn't mean that your quiz 1 score causes your final score. But what it does say is that those two things are related, but we can't say that X causes Y. Now, our last type of research, our experimental research, starts to be able to get closer to establishing causal relations between different variables. Okay. With experimental research, this is a method in where we're using where we're taking some variable procedure and we're manipulating it to look at an effect on an outcome. So we, as experimenters, are going through and we're actually manipulating or changing something, okay? And this experimental manipulation is the defining feature of experimental research. If you don't have an experimental manipulation, if researchers aren't doing something different for one group versus the other, then we don't have an experimental research, experimental study. But when people get in there and we say, all right, this group gets this condition, that group gets that condition, and we're actively changing something, keeping everything else the same. So nothing is different on average across these groups, except for the one thing that we've changed. This starts to help us establish something that is stronger evidence for a causal relationship. So again, with experimental research, the manipulation is the defining feature. All other things kept identical except that experimental manipulation. So if we see that group A group differs from group B, the only thing that's different in those two groups is our experimental manipulation or whatever we've done, and so that's the defining feature of our experimental research. This can get a little bit tricky, so I want to walk you through everything about experimental research. First thing we need to do is identify the population we're interested in working with. Okay, so who's in general the group of people of interest, right? But because it's a study and we have limited time and resources, we can't study everybody, right? If our population of interest is American citizens, we clearly can't have all American citizens in our study. But what we can do is we can pull a sample. Okay, and so we have a smaller subset of the population we're interested in. So if our population is United States citizens, then we go through and we grab a sample of individuals who are citizens. Or if my population of interest is college students, I obviously can't study all college students, so I'm going to get a sample of college students. Okay, and once I've got my sample, I'm going to go through and I'm going to divide my sample up in, let's say, two different groups. This is just one example of an experimental study. Very simple. But what I'm going to do is I'm going to go split these up, and I'm going to have an experimental group and a control group. Okay, and the difference between those two groups is going to be my independent variable. Independent in that it's not dependent on anything except for me saying that this group gets this thing, that group gets that thing. Okay, so our independent variable in an experimental study is the thing that we're manipulating. All right, and we'll go through examples of this in a moment. Now, one of the things that we want to be mindful of is this idea of random assignment. Okay, if I go through and I say, okay, all my men are in the experimental group, all my women are in the control group, that's not a good group assignment because Maybe if I see differences across these groups, it's not because of what I've done. It's because that men are different than women for some other reason. And so what we want to do in our best case scenario is we want to randomly assign our participants to either our experimental group or our control group. That's our comparison group, our baseline group. Okay, so what I do in my experimental study is I have my two groups, and these groups are on average no different from one another outside of whatever it was that I had them doing. And so then we go through and we measure some outcome in both groups. Okay, this outcome is our dependent variable. This is our outcome measure. Okay, and if we go through and we find that after we've implemented this experimental manipulation, if we see differences in these two groups, then what we are inferring is that whatever we did to make these two groups different from one another has then caused the difference that we see here on the outcome. Okay, because if we've randomly assigned people to conditions, right? If we just randomly say, you go this way, you go this way, so before we do anything, these two groups are functionally equivalent. If the only thing that makes the outcomes in these two groups different is the thing that we did here, then we can say that whatever we did in our experiment has then likely caused whatever outcome that we've got here. Okay, and so when you get into the nuts and bolts, it's a little more complicated than all this, but this is the general idea behind an experiment. So it's not like descriptive research where we're just kind of going through and taking notes and making observations. And it's not like experimental research where we're getting numbers, right? And we're looking at this with some statistics, but with correlational research, we're not doing anything. We're not implementing any type of experimental manipulation. Here we are, and what we're interested in looking at is whether or not we see differences in these groups. So, for example, let's say our research question is the impact of breastfeeding on intellectual ability, right? If you look at popular research suggesting that breastfeeding is better than providing infants with formula. And so what we can do is we can test this with an experimental study, right? So maybe our population here is all children, right? We can't study all children. So what we do is we get a sample of mothers and children, right? And we recruit them for our sample, okay? And then what we do is we randomly assign mothers to two different groups, right? In our control group, we have mothers using formula. In our experimental group, this is the mothers we're going to have and go through and breastfeed. Okay, so we've randomly assigned these. So the two groups shouldn't be different systematically from one another, except for this group is breastfeeding their children. This group is using formula. And then let's say what we do is we go through and then later assess these kids, give them an achievement test at age 6. And if we go through in age 6, find that our children who were breastfed as infants tend to score higher than our children who received formula in this controlled experiment, that starts to give us some evidence that maybe breastfeeding does have an impact on outcome, because everything else has stayed the same except for the one thing that we changed here. Okay, another example. Let's say we've noticed through our descriptive research, through our descriptive studies, that people tend, once you've had alcohol, people tend to think it changes people's perception of attraction, right? You're hanging out in bars and watching people drink, and you're like, wow, it seems like people tend to be find people more attractive after they've been drinking. So what we can do is we can study this with an experiment, right? So we get a sample. Okay, we have, let's say, students coming into the lab, men and women coming into the lab, and we then assign them randomly to two different groups. Our control group, our experimental group gets some level of alcohol, right, that we're providing them. Our control group maybe gets something that tastes like alcohol, but isn't actually alcoholic, right? We don't want people to be able to tell which group they're in, and so in our control group, we're going to give them a placebo drink that might taste a little bit like alcohol, but has no intoxicants in it. There's nothing that they can go through and actually get them intoxicated. And so, and then what we do after we've given them 2-3 drinks is then we give them some pictures. And we say, okay, I want you to rate how attractive you find the people in this picture, right? And so we rate their average rating of attractiveness. And if, again, at the end of the study, we find that people who we gave actual alcohol to tend to rate these images, these pictures of people as more attractive than the people who got whatever placebo we gave them, then we might have evidence that, yeah, it looks like alcohol consumption does alter people's perception of attractiveness. And we do know from research that this looks like people who are intoxicated have impaired ability to detect symmetry. Symmetry is something that often is associated with attractiveness and human faces and things like that. And so this is something that we could actually do and find. Okay, so in both of these studies, what we've done is we as researchers have actively gone in and changed something. We said on average these two groups are different only on the thing that we've gone through and manipulated, and so then if we later see differences in that outcome, in that dependent variable, we would say that then we have at least some evidence that whatever it is that we changed then causes differences in our outcome. Okay, and so that's the fundamental core features of an experimental study. Now, our experimental research, this is kind of our gold standard for trying to establish causality, but again, we have limitations, right? One thing we're worried about is placebo effects. Okay, placebo effect is that if I give you something and you think you're supposed to respond to it in some way, then you might start responding to it in a way that would be consistent as if you actually got it. So let's think about we have people who are experiencing some level of pain, and we give them a pill and say, here you go, this will make you better. And they take the pill and they're like, oh yeah, I feel a lot better. What that might have been was a sugar pill or some pill that didn't have any active ingredient in it. And what we've got there is a placebo effect. I gave you something that you thought was going to work. And because you felt it was going to work, then it actually did sort of, at least subjectively, reduce your perceptions of pain. That would be a placebo. And so what we want to do with our experimental designs in our control group is have something that tries to account for this placebo effect, right? So in our alcohol example, we might give people in the control group some sort of beverage that tastes like alcohol so that they don't think that, oh, I just tasted this, there's clearly no alcohol in this, and so I'm not going to respond, right? Same type of thing with a drug trial. We don't want to just give medications and have the people in our experimental group take the pills and the people in the control group not take anything, because then people in the control group are probably going to understand that they're not actually actively getting medication, and that's going to mess with things, right? So what we do is we have a placebo control, and these are going to be individuals in our control group. They're going to get the same pills. They're going to look the same way as the pills we're giving for our experimental group. They're just not going to do anything, right? And we use this to try and address some of the limitations of our experimental research. But sometimes this gets difficult, right? If I'm doing a psychotherapy study, right, and so I've got people coming in and I'm giving them some active treatment, what's my control group looking like, right? Just talking with people and letting people come in and share their thoughts and feelings is probably going to do something, right? And so I don't have just a straight up, it's hard to come up with, and it starts to get difficult to think about what's going to be our control group for psychotherapy. Essentially what we want to do is have something that does nothing, but it's hard to just, the very act of coming in and talking with someone is often kind of helpful. And so this placebo effect starts to get a little bit difficult depending on what types of study that we're doing. Other concern that we have with experimental research is external validity. Okay, external validity, same thing as ecological validity. We might bring people in, and within the context of a study, be able to determine that if we do this to this group and that to that group, then we get some differences in some outcome that we're looking at. But it can be hard sometimes to determine whether or not whether whatever we've done in this lab at the university that's far removed from what actual people actually experience, whether or not that's going to translate out into real world experience. So did we just do something cute that's a fun parlor trick in the lab? Or is this something that actually reflects a true phenomenon out in the universe? And so we have, with certain types of research, some concerns with external validity. Okay. So last thing we're going to talk about here in this last slide is how we go through and analyze our data, okay? Because if we go through and we run our studies and we see a relationship between X and Y, or we see differences across groups based on our experimental manipulation, our values are never going to be identical. The values we find in group A and the average value we find in group B are never going to be exactly the same number. So the question is, are the differences we've seen reliable and meaningful, right? Always two explanations for patterns that we see in our data. One, this pattern is a real meaningful relationship, right? We see that, yes, systematically and reliably, scores on quiz 1 predict outcome in the class in terms of final grades. And yes, the difference that we see in ratings of attractiveness of people who are drinking alcohol are systematically higher than and consistently higher than people who don't drink alcohol or who haven't been drinking alcohol. Okay, so we've got a real meaningful effect. Or the difference that we have is just associated with random fluctuations of data, not meaningful at all. Okay, so let's say I'm standing in front of you all in class, and I say, all right, my hypothesis is that individuals who sit on the right side of class are inherently taller than the people who sit on the left side of class. Okay, and I go through and I measure everybody's height. So everybody on the right side, I measure their height, measure the height of everybody on the left side. Everybody on the right side is on average 5'10". Everybody on the other side is 5'9". I got a 1-inch difference. It's in the direction that I had hypothesized. I say, yeah, look at there. People who are taller inherently always sit on the right side of class. People who are shorter always sit on the left. Well, there's no reason for that to be true. My data might have been consistent with my hypotheses, but that difference that I find probably isn't meaningful, right? But it can be tough to determine whether or not we have a real effect or whether or not we were just observing random fluctuations. This is where inferential statistics come into play. Our inferential statistics help us distinguish between things that are meaningful, reliable effects and things that are just random fluctuations. And we're looking at we would say that we've achieved statistical significance in this relation between quiz 1 scores and outcome, or in the relation between alcohol use and attractiveness, things along those lines. Okay. Now this is an intro psych course, not a statistics course, so we're not going to get into the nuts and bolts of how inferential statistics work, but a couple of things we want to have a general sense of in terms of statistical analyses. One is our measure of central tendency. Measure of central tendency is functionally our middle score. What's our most representative score in the sample? This is oftentimes an average of the scores in this group versus the average of the scores in this other group. Looking for kind of that middle score. Okay, so if this is, say, the distribution of IQ scores, and we have right here the middle score, the average score, the median score in this distribution is going to be 100, right? And so we say, we know that people aren't always going to have an IQ of 100, but if we give assessments to a large number of people, on average, people tend to score about 100. This is our measure of central tendency. Okay. Our other statistic that we think about is variability. Variability refers to how spread out scores are, right? So do we see everybody kind of the same, or do we see people tend to vary around and are quite different? And so we tend to see variability expressed in things like range or other statistics called standard deviations. You don't have to worry about what that is. But in general, how spread out are scores, right? So in our class, if you think about our class, looking around people in there, if I were to collect the age of everyone in our class, we're probably not going to have a whole lot of variability in that in age, right? Everybody's probably somewhere between 18 to 21, right? Actually, our average is probably going to be somewhere around 19, but people aren't going to differ too much of that. You know, some people might be a little bit older, some people might be a little bit younger, but there's not going to be a ton of variability in that, okay? Now, if we were to measure everybody's weight, that's going to have much more variability, right? A lot more differences in terms of people's weight than their age, because we're going to have men, we're going to have women, we're going to have people who are bigger, people who are smaller, a lot of variability. And so if I were to say which one of these variables age or weight is going to have greater variability in our class. Greater variability in weight. Age is going to be quite narrow, just given the makeup of our class. Okay, so central tendency, the middle, variability, how spread out our scores are, how spread out or different do we see things. Okay. All right, that does it. Thanks for hanging in there with me. And again, we'll not do too many of these where I'm forcing you to go on and pick up lecture slides with these videos. But do make sure that you go through, take a look at the lecture summary. Make sure you take a look at the comprehension check. If you can go through and answer these questions without looking back through your notes, feeling pretty confident about that, you should have a pretty good handle on some of this research method stuff. So thanks. I hope you guys are having a great break, and we will see you on Wednesday for our quiz. All right. Thanks a lot.